Ladies and gentlemen, theys and thems, whoever's watching. Today we're going to be talking about chemistry in the brain. And looking at my background, you guessed it, we're talking about neurons, more specifically neurotransmitters. These are the things that will control your mood, your concentration, your ability to learn, and so much more. So let's get started. All right, so to begin, I wanted to show you guys the 8 main neurotransmitters that there are. There are actually 3 major categories: amino acids, peptides, and monoamines. But here we actually see the structure of them. So the chemical structure, we have carbon, hydrogen, oxygen, nitrogen. Those are the main elements in these neurotransmitters. Just to talk about 2 of them specifically, GABA and glutamate. Those are the 2 common ones in the brain. Glutamate actually is called glutamic acid. It's one of those excitatory neurotransmitters. GABA is an inhibitory one. And I'll talk later on about what exactly that means. But yeah, GABA is a calming neurotransmitter. And glutamate, it's focused more on memory, learning. It regulates your development. And then there's other neurotransmitters like, endorphins control euphoria, serotonin affects your mood, happiness, dopamine, pleasure, adrenaline, noradrenaline kind of both have to do with fight or flight, except noradrenaline is more of the relaxation that comes after fight or flight. So here's an overview of neurotransmitters. Here we have the axon terminal, all right? This whole thing right here that we're looking at, a postsynaptic neuron. Okay, that's what this is. This is the axon terminal. Stay with me, because right here we have neurotransmitters, these little green dots, and they're located within synaptic vesicles. There's 4 of them in this image. What happens is that they get released and diffuse right here along the synaptic cleft. And they don't stay in the synaptic cleft for very long because they're going to need to either get metabolized by enzymes or pulled back into the neuron through something called reuptake, which I'll talk about later. But, what happens here is that there is a transmembrane ion flow, okay? So that can either increase or decrease the action potential. So when you're increasing action potential, that's excitatory. And when you're decreasing, that's inhibitory. But the binding of the neurotransmitters could either excite or inhibit, and that would lead to depolarization or repolarization, respectively. So now let's talk about action potential. I just mentioned it, but what is it, right? We mentioned it briefly, right? There's going to be either excitatory or inhibitory ion flow. Right here, action potential. It travels across the axon, as the arrow indicates, and it causes a release of neurotransmitters into the synapse. What does this mean? This transmitter release, the action potential, it's going to allow the neuron to communicate with other neurons. Transmitters get released, and then it allows for communication. That's really what it is in its essence. Now let's talk about that depolarization, right? It's, there's an electric charge. And what's going to happen is that there's going to be a change. You're going to end up with less negative charge inside of the cell. So in this image here, you see there's sodium, right? Here, the channel is open. There's a channel. It's open. It's allowing these positive charges to go inside the cell. And when the channel closes, it's inactivated. Depolarization is done. And what you're going to end up with is just an overall more positive charge inside the cell, so less negative charge. On the other hand, we're going to talk about repolarization. All right, now we're going back to that action potential, right? So repolarization, it's basically returning to that negative charge. So you can see here, we have a resting state, right? Depolarization, that's gonna create that positive charge. And then repolarization is it's gonna go back to the negative charge, and then eventually it's gonna go back to a resting state. So that's basically what repolarization is. So now let's talk about reuptake. Reuptake, it's the reabsorption of a neurotransmitter by a neurotransmitter transporter located along the plasma of an axon terminal after it transmitted a neural impulse. You can see here in this image, right? Here we have it. Here's the impulse. Here is the reuptake of the protein. It's going back up into the neuron. That's basically what's going on. It's just going back up into the neuron. That's all that's happening. After it already transmitted some sort of neural impulse. Okay, now let's get down to the nitty gritty. You guys want to hear about some of these things that happen in your brain. Well, one of the most exciting ones, in my opinion, is dopamine. So let's talk about dopamine synthesis in the brain. Well, before I get into the details, dopamine, that's the type of thing, right? We mentioned it controls kind of like feel-good emotions, pleasure. There is this chemical called tyrosine, and it can't be made in the brain. It can't be made. You're going to need some sort of transporter. Yeah, there's a large neutral amino acid transporter. And by the way, dopamine is one of those monoamines. But tyrosine, right? We need it. And we're going to use it once it's actually in the brain with that transporter. We're going to use it to create dopa, dihydroxyphenylalanine. You know what? I'm sorry. I tried my best. By the tyrosine hydroxylase enzyme. And you know what? We're going to take tyrosine and we're going to take oxygen, THB, and iron. THB, that's tetrahydrobiopterin. It's gonna combine with this, and it's gonna convert to dopa. That's dihydroxyphenylalanine. That's a mouthful. And now once you get this, right, high concentrations of dopamine are going to inhibit that tyrosine hydroxylase through the influence of that THB. And now you're going to have dopa. And it's going to be converted to dopamine through aromatic amino acid decarboxylase using pyridoxal phosphate, PLP. And you end up with dopamine. That's real fun, That was a lot of words and they were huge, but you end up with dopamine here. And related to that, no epinephrine synthesis. No epinephrine is synthesized from dopamine. You learn more every day. And this is done through the enzyme dopamine beta hydroxylase, or DBH, using oxygen, copper, and vitamin C. You can see right here. Dopamine is synthesized in the cytoplasm, but no epinephrine is synthesized in the neurotransmitter storage vesicles. So you can see here, it goes from dopamine to noradrenaline. That's that process. Here are my references. Please ask me any questions you have. And yeah, those are the chemical processes in the brain. Not all of them, but some of them. Thank you.